Hi, Assalamualaikum. My name is Shahrul Anuar bin Mohammad Yuslee with student identity 2019704843. This is my final year project with topic strength analysis of J-hook of various cross-section and my supervisor is IRTS Dr. Mohammad Azzeim bin Jusoh. Before you know about my final year project, I would like to show my project background. So here, the picture A showed the I-shaped carabiner, while picture B showed the circular shape of carabiner. There are difference between these two designs while the use is the same. So my project has used the concept of these two designs. Here the picture C shows one example of the application for the carabiner, which is rock climbing activities. The problem statement of the studies is the widely use of common design of hook in our globalization. Furthermore, the design of the cross-section is not optimal according to the several design. Next is with the same amount of material, it can reduce the cost of producing the product and also the weight of the product. The objective of my final year project is to validate the same amount of area but different in cross-sectional area has different in strengths, because if we use the different amount of area, it will probably give the different result. So in this project, it used the amount of 100 millimeter square as the area. Between the design that has been created, another objective is to validate a good concept of cross-section design. So we can choose the best design of cross-section for the hook design. Furthermore, with these studies, it can create an improvement for the hook design and change the common design for the general usage. On this slide, it shows the scope of work for this project. So for the design, there are 4 designs has been created. The first 2 design is a common design, as we can see everywhere, which is circular shape and square shape. For the next design is I-shape and T-shape design. This design has been followed as the structure of a beam that has been used in a heavy industry structure. In addition, the another variable for analysis in this project is by using 2 types of material. The material that has been used is nylon 101 and polylactic acid, which is known as PLA. The reason for picking this material is because this material can be created a rapid prototype in 3D printing machine, and the material has a different in strength and elasticity. During the analysis, there are 2 types of mesh size that has been used to get a better result, which is for fine mesh, there are 0.1 mm of element size and 0.05 mm for their tolerance, while for the coarse mesh, there are 4 mm for element size and 0.2 mm for the tolerance. The analysis of the project has been used the finite element analysis that has been created in SolidWorks 2020 software. Next, I would like to explain about project methodology in this final year project. First, I would like to start with flowchart. This flowchart is show the flow of the project in roughly. So as you can see, after I start the project, I make a literature review about the topic. So I study on the previous studies to find the information. Next, I identify the problem. To create the objective, I need to have the problem and find the solution. After that, I brainstorming on the project to create the design of the hook. Furthermore, I make an analysis through the SolidWorks software to know about the strength of the project. Then finally, result and discussion can be generated after the analysis has been done. Lastly, the conclusion for the entire project can be done. The beginning of the design for the final year project is to create a main body frame. The main body frame is important for this project to ensure we achieve the objective. Every design of cross-section area for the hook need to follow the requirement of the main body frame. It is to ensure the size of the hook remain the same for every design, so we can get the better results. The L shape that has been used as the main body frame, it is because the force can be applied and separated uniformly in one direction, and the L-shaped body frame is easier to understand the stresses. Furthermore, the displacement of the object can be identified and compared clearly through this shape, as we can measure the displacement at the straight point. This slide shows the detailed design of the cross-sectional area. For circular shape, the radius has been used is 5.64 mm. The diameter was used to ensure it get 100 mm square as the cross-sectional area, and the weight for the entire hoop is 4.57 grams. Next is square shape. This square shape use 10 mm base and 10 mm wide, so the cross-sectional area can achieve 100 mm square, and its weight for the entire hoop is 4.6 grams. Next, for I-shape and T-shape, the base dimension that have been used is 10 mm. The reason to use this dimension is to ensure the contact area for the force can be remain the same. As here will show the calculation to calculate the cross-sectional area for this hoop. And also same as others, the area must in 100 mm square, and the weight for I-shaped hoop is 12.07 grams, and while the weight for T-shaped hoop is 11.74 grams. Furthermore, this slide shows the free body diagram. For this 4-hoop design, on the top of the hoop, there are reaction force. The reaction force will react at the top of the hoop are considered as a fixed geometry. And then they will apply force, and the force 10 kg of weight will attach as external force for the project, and then they will show the weight of the hoop will react follow the gravity. For this slide, it shows the finite element analysis. This picture shows the stress, displacement, and strain of the hoop. As you can see, there are multiple colors at the hoop, and it is clarify the stresses of the hoop. At the data on the right, it shows that the red is the critical and blue is the fine stress. The way to test the hoop is by hanging a load of 10 kg at the hoop. Now we continue at data and result. This is the result for nylon 101 with fine mesh. The most highest vermicellar stress for this material is at circular shape hook design. It gets 9.27 times 10 to the power of 7 Newton per meter square, while the lowest of vermicellar stress is T-shaped hook design, which is 1.262 times 10 to the power of 7 Newton per meter square. For the displacement for this material, the square-shaped hook design has the highest displacement, which is 25.09 mm, while T-shape has the lowest, which is 2.618 mm. And the highest for the strain is at circular shape, which is 7.255 times 10 to the power of negative 2, while the lowest is T-shape with 9.766 times 10 to the power of negative 3. This is the result for nylon 101 with cross mesh. The highest vermicellar stress is at square shape with 1.202 times 10 to the power of 7 Newton meter square. But the result has slightly different with the circular shape, which is 6.138 times 10 to the power of 7 Newton per meter square. For the lowest vermicellar stress is at T-shape, which is 1.146 to the power of 10 Newton per meter square. Next is for the displacement. The different at this mesh get different result as the fine mesh even it use the same material. The highest displacement for this part is square shape hook design. The displacement for the square shape is 24.95 mm, while the lowest remain the same, which is T shape with 2.599 mm. The highest strain is at square shape, which is 4.147 times 10 to the power of negative 2, while the lowest is T shape at 8.293 times 10 to the power of negative 3. This is the result for polylactic acid with fine mesh. The highest permisses for this material is at circular shape, which is 8.989 times 10 to the power of 7 Newton per meter square, while the lowest is T shape with 1.222 times 10 to the power of 7 Newton per meter square. The highest displacement were taken at square shape with 27.11 mm, while the lowest displacement is at T shape with 3.139 mm, and the highest strain is circular shape with 8.682 times 10 to the power of negative 2, while the lowest is T shape with 1.20 times 10 to the power of negative 2. And the slide show the result for coarse mesh of polylactic acid. For highest vermices stress is at circular shape, which is 5.854 times 10 to the power of 7, while the lowest is T shape with 1.143 times 10 to the power of 7. The higher displacement is square shape, which is 19.44 mm, while the lowest is 3.117 mm. For the strain, the highest is square shape with 4.849 times 10 to the power of negative 2, while the lowest is T shape with 1.023 times 10 to the power of negative 3. As a conclusion, due to the project, the difference in shape show it affect its strength. Even with the same amount of area, it can give extra strength if the design were perfect. The square shape is not a good choice of making a hook design, since all the analysis show that the square shape has a very high displacement, while the T-shape is the best option for the design of cross-sectional area. For this analysis, it can simply say that by knowing the strength can give an impact to reduce the weight, cost of material, and producing time of the product if they will use a perfect shape of design. And here is the reference to complete and support the final year project. That's all from me, and thank you.